Today I am excited to present my analysis of housing prices using Ames housing dataset through linear regression. Let's walk through the step of process, highlighting the purpose and significance of each code segment. This is a import library part. To begin with, I have imported essential libraries: pandas for data manipulation, numpy for numerical operations, matplotlib and seaborn for visualization, and modules from scikit-learn for model building and evaluating. Each library plays a vital role in ensuring we can efficiently analyze our dataset. And Next, I loaded the Ames housing dataset into a pandas data frame using the read CSV function. This dataset contained a wealth of information about different properties and their sales prices. After reading the data, I displayed the first few rows to get overview of its structure and the type of information we are working with. This step is crucial for understanding the dataset's context and identifying potential areas for analysis. In the next step, I check for missing value in the dataset. Missing values can significantly affect our analysis, so it's vital to identify and address them before proceeding. To handle missing value, I implemented a strategy where numeric columns were filled with their means value, while categorical columns were filled with the most frequent value. The approach helped maintain the dataset's integrity, allowing the model to learn efficiently. Next, I encoded categorical variable using one-hot encoding. By converting these variable into a numerical format, we enable the linear regression model to interpret them correctly. Then I define features and the target variable self-price. Features are the independent variable that we will use to predict the target variable. In the next phase, I split the dataset into training and testing sets using 80% of data for training and 20% of testing. In division allows us to evaluate the model's performance on unseen data, ensuring that it generalizes well. Then I create a linear regression model using scikit-learn's linear regression class. Linear regression is a fundamental statistical method that helps us understand the relationship between variables. After creating the model, I fitted it to the training data. This process involves adjusting the model's parameters to minimize difference between predicted and actual values. Following the model fitting, I made predictions on the test set. This prediction will help us evaluate how well our model performs on data it has not seen before. To evaluate the model's performance, I calculate the mean squared error (MSE) and R-score. The MSE gives us the average square difference between prediction and actual values, while the R-score indicates the proportion of variance in the target variable explained by the model. And Then I printed the evaluation metrics to the console. This value provided the clear indication of the model's accuracy and effectiveness in predicting housing price. Finally, I visualize the relationship between actual and predicted price using scatter plot. This is plot allows us to see how closely our prediction align with the true value. The red dashed line represents the ideal scenario where predicted prices equal actual price. This is my chart. In conclusion, in this analysis of the Ames housing dataset through linear regression demonstrate the power of data-driven insight in understand housing prices. By leveraging data preprocessing, features selection, and model evaluation, we can make it informed prediction that hold real-world significance. Thank you for all. Thank you for your attention.